Welcome to all of you. Today we discuss MCQ 2022 paper DSC B2.3 Advanced Mechanics. Question 1. Two particles are connected by a rigid weightless rod of constant length. The degrees of freedom of this two-particle system, correct option is 3, correct option, answer is 5. And this system, two particles are connected by a rigid weightless rod. So A and B are two particles, coordinates A, coordinates of A, x1, y1, z1, coordinates of B, x2, y2, z2. And this system consists of two particles, so capital N equal to 2 with one constant x2 minus x1 square plus y2 minus y1 square whole square plus z2 minus z1 whole square equal to L square, where L is the length of the connecting rod and the points A and B are the coordinates with coordinates x1, y1, z1, x2, y2, z2 of these two particles. Hence, the number of degrees of freedom equals to 3n minus k. So here 3 into 2, number of particles, minus 1 is the number of constants. So it is equal to 5. Hence, the correct answer is 5 of this system. Next question, 1b. The Lagrangian for a simple pendulum of length L and mass of the bob small n with angle of deflection theta is given by, the correct answer is 1. L equal to half of ml square theta dot square minus mgl bracket 1 minus cos theta. Here the arc OA arc length arc of the length OA equal to small s, and this the CA distance CA is small l because the length of the simple pendulum is small l. So this CA is the point of suspension is C, and theta is the angle at the position A from the position OB, mid position OB, and so is equal to L theta. Then the velocity V equals to ds by dt and equal to ddt of L theta, and L is constant, so L d theta dt equal to L theta dot. Then the kinetic energy T, capital T, equal to half mv square equal to half m v equal to L theta dot whole square, so half m L square theta dot square. And the potential energy at the point O, at this point O, equal to 0. Then potential energy at the point A, so this is equal to VA equal to mg into height OB. OB is the height, vertical height for the position A from O. So mg into bracket OC minus BC. OC is the length of the pendulum minus BC. So this equal to OC equal to L and BC equals to L cos theta. Obviously, because this is theta and this is the from the right angle triangle, we can easily find BC equal to L cos theta, BC by L equal to cos theta. So mgl bracket 1 minus cos theta. Hence Lagrangian L equal to T minus V, kinetic energy minus potential energy. So this equals to T equal to half ml square theta dot square and V equal to mgl bracket 1 minus cos theta. Hence L equal to and this expression first answer is the correct answer. Option is the correct answer. Next question 1C. The expression for kinetic energy E of a particle of mass m in cylindrical polar coordinate system r theta z is given by, the correct option is 3, t equal to this. In cylindrical coordinates, the generalized coordinates are q1 equal to r, q2 equal to theta, and q3 equal to z. The orthogonal unit vectors are r cap, theta cap, z cap. The position vector of a point is r vector, that is equal to r cap plus z into z cap. So this is the coordinate system. This is the x-axis, this y-axis, the z-axis, and this is the r in the direction of r, and this is the theta. This is the angle theta, and this is the point P with coordinates r theta z, and this is the distance, vertical height is z, and this is the direction of theta cap, and this is the direction of z cap, and this is the direction of r cap. So obviously r vector, this r vector is OP vector. Obviously r into r cap. So this distance r distance r into r cap plus z into z cap. So OP vector equal to this vector plus this vector. Also dr cap equal to d theta into theta cap. Dr cap equal to d theta into theta cap, and d theta cap equal to minus d theta into r cap. For scleronomic system, the velocity of a point is given by r vector dot equal to dr vector dt equal to summation over I del qi r vector into qi dot. This equals to del q1 r vector q1 dot plus del q2 r vector q2 dot, this qi vector, and del q3 r vector q3 dot, and hence we get value, putting the value q1 equals to r vector q2 equal to theta, and q3 equal to z. So putting these all these we get this del r of r vector r dot plus del theta of r vector r theta dot plus del z of r vector z dot, and the value of r vector equal to r cap plus z cap. So we put this value and this r dot and theta dot equal to this. So value of r dot, value of r vector, value of r vector, and z dot. After differentiating, partial differentiating with respect to r, so we get this, and with respect to theta, and differentiating partially differentiating with respect to theta, and partially differentiating with respect to z, we get this result, and we get r vector dot equal to r cap r dot plus r theta cap theta dot plus z dot z cap, and hence r dot square equal to r vector dot and dot product r vector dot. This dot means dt, and so this vector dot this vector, and hence this r dot square r cap square means 1, r square theta dot square theta cap square means 1, and z dot square and z cap square means 1. So kinetic energy T equal to half m r dot square. So this equals to half m r dot square plus r theta dot square plus z dot square. And hence the expression of kinetic energy T equal to half m r dot square r square theta dot square and plus z dot square. Question D. Transformation of Lagrangian to Hamiltonian is done by Legendre transformation. Also, previous question, you can alternatively find this expression of R by putting this generalization alpha 1, alpha 1, 1, alpha 2, 2, and alpha 3, and so on. Basic idea behind the Legendre transformation is to construct the Hamiltonian H QI from the Lagrangian L Qi, Qi by eliminating Qi dot from L in favor of Pi's generalized momenta as H equal to summation Pi Qi dot over I, summation over I equal to 1 to small n minus L. So, we can find H from Lagrangian L by replacing by Qi dot by generalized velocities by generalized momenta, and behind of this transformation by the behind of this relation Legendre transformation of this. Next question. The Hamiltonian of a plane pendulum of length L and mass of the bob m is given by this, but this question is wrong question. Uh, Actually, wrong answer. There is no correct answer here, because kinetic energy here, the pendulum with length L, small m is mass is small m. So kinetic energy T at any point, arbitrary point P, half of m into s dot square. S dot square is the arc length OP. So s equal to L theta. So s dot equal to L theta dot. So half of m L square theta dot square. And at this point P, potential energy V equal to mg into height OQ, vertical height for the point position P from the mid position O. So this OQ means OS minus SQ. OS means L, length of the pendulum, and QS equals to L cos theta, because from this right angle triangle SQP we get QS by L equal to cos theta. So MAGL bracket 1 minus cos theta. Since the given system is conservative, so Lagrangian L is given by T minus V. So T equals to half ml square theta dot square and V mgl bracket 1 minus cos theta. So Hamiltonian H equals to T plus V. And so Hamiltonian T half ml square theta square plus m a gl 1 minus cos theta. So Hamiltonian correct option, there is no correct option. So correct answer is this: H equal to half ml square theta dot square plus mgl bracket 1 minus cos theta. Theta is the only generalized coordinates here. Next question. If the action of the path of a physical system is given by, correct option is 2, T0 integration T1 L of Qi dot T dt. Action of the path of the physical system given by this. Now Lagrangian L is the function of Qi generalized coordinate, Qi dot generalized velocities and time t. The accentrical I integration T0 to T L Qi dot T dt. And so by the definition of the accentrical, we can easily find this. Question G. The Lagrangian of a system in two dimensions is given in Cartesian coordinates xy, L equal to half mx dot square plus mx dot y dot. And px, py are the momentum conjugates corresponding to coordinates x and y respectively. Then Hamiltonian age of the system is given by the correct option is 3. Here px equals to del x dot L. So del x dot L is given here half mx dot square plus mx dot y dot. So after differentiating partially with respect to x dot, we get mx dot plus my dot. And also py, that is equal to del y dot of L. So del y dot of L is this, so this is equal to mx dot. Now L equals to half m x dot square. So value of x dot is py by m, and value of uh, x dot y dot. So value of x dot is this, and value of y dot we can find from the first relation px equals to mx dot plus my dot. So my dot equal to px minus mx dot. So from this y dot equal to px minus py by m. So this is the y dot, value of y dot px minus py by m. Hamiltonian H equals to summation of this uh, p into q dot. So x dot px plus y dot py minus l. So x dot py minus m and y dot equal to px minus py by m into py minus l, and value of l equal to this. After simplification, we get the result is equal to px py by m minus py square by twice m is the correct answer. Next question, H. If kinetic energy T does not depend on generalized velocities Qj dot, the generalized force capital Qj of the system with Lagrangian L is given by, no correct answer here. So this is the wrong answers here. Now the Lagrange's equation of motion, we know ddt of del T del Qj dot minus del Q del Qj T equal to Qj. And T is the kinetic energy, capital Qg is the jth component of the generalized force. If T does not depend on the generalized velocities Qg dot, here in the given question, uh, T does not depend on the generalized velocities Qj dot. So del T del Qj dot equals to 0. So we get del Qj T equal to minus Qj. That is Qj equal to minus del T del Qj. But here option, first option is this, second option is this, no negative minus sign here, and third option is this, no negative sign here. Actually option 2 is correct if we put here negative sign here, q capital Qg equal to minus del T by del Qj. Sorry, option 4 is correct if we put negative sign minus sign before del Qj T. Correct option is 4 if we put here negative sign here. Now another form of this question is this: if T is a function of Qj dot and V is a function of Vqj, potential energy, then del Qj dot L equal to del Qj dot T minus del Qj dot V, because L equal to T minus V, Lagrangian rule. So del V del Qj dot equal to 0, because V is a function of Qj, not Qj dot. So obviously del Qj dot V equal to 0. So del Qj dot L equal to del Qj dot T, and del Qj dot equal to del T del Qj dot minus del V del Qj equals to del V del Qj. Since del T del Qj equal to 0, because T is a function of Qj dot, so not Qj. So del T del Qj equal to 0. This term is 0. So del L del Qj equal to minus del V del Qj. Now, if capital Qj equal to minus del V del Qj, then capital Qj equal to del L del Qj. Since del V del Qj minus is equal to del L del Qj. Next question. In Hamiltonian principle, the action integral I integration t1 to t2 L dt is stationary for arbitrary variation of the path in the H space, in dimensional space, Rn, configuration space, and state space. And actual the correct answer is configuration space. And the definition of configuration space, which is the n-dimensional Euclidean space with in generalized coordinates q1, q2, qn, such that the coordinates of a point q in the space as q equal to q1, q2, comma, dot dot qn, first bracket, within first bracket, n tuple of coordinates is q point, and this space is called configuration space. So this Hamilton principal action integral is stationary for arbitrary variation in the path in the configuration space. And last question J. If H be a Hamiltonian, with the Hamiltonian of a given dynamical system with 1 degree of freedom, for which the Poisson bracket P capital H equal to 0, Q being the coordinate and P being the conjugate momentum, then correct option is P is constant. P is constant. Poisson bracket P and capital H, this equals to del P del Q, del H del P minus del P del P, del H del Q. Obviously, del P del Q 0. This P is generalized momentum, and Q generalized coordinates. P doesn't contain the variable Q, so this term 0 and del P del 1. So we get minus del H by del Q, and this equals to minus P dot, obviously. Now, here, del H by del Q equal to 0. Because Hamiltonian the system with 1 degree of freedom, this Poisson bracket equal to 0. So Poisson bracket equal to 0 means del H del Q equals to 0. And this implies P dot equal to 0. P dot means del T of P equal to 0. And this implies P is a constant of motion. Thank you.